Welcome to video 1.6. In this video, we're going to cover two parts. We're going to do proportional parts in triangles and proportional parts when parallel lines are cut by transversals. So we're going to have two situations. We're going to deal with this one first, I think. So what I want you to do is let's draw a set of three parallel lines. And we're going to cut those parallel lines by two, what we call transversals. One going like this. Let's send the other one going like that. So these are running parallel. And I've got two transversals slicing them. And you'll notice that we've got lots of parts in here, like this length, this length, this length, this length, and they are proportional. So what we have, if I were to label them, I'm just going to label this one A, B, C, and D. And those are representing the lengths of those parts between the parallel lines. And they are proportional. So A is to C in exactly the same way that B is to D. Also, this whole chunk, for example, I could say A, let's put a comma here, A plus B is to any, let's say this, C plus D over any other pair of corresponding parts, like as B is to D. Or I could even say A is to this whole way as C is to this whole way. All those pieces in there are proportional. So when you're missing a side, you can just, or a singular piece in here, you can just set up a proportion and solve it. And it has to do with extending these to make triangles, and we can make them. Sorry, there's an announcement right now. So let's go take a look at the other picture that we're going to be dealing with these. Let's go throw triangle out here. And let's suppose I bisect this angle so that this one is the same as this one. We also have a theorem that says that this side's pieces that got chopped, and let's go call these two pieces A and B, and let's call these two C and D. So we can also say that A is to B as C is to D. So this got chopped proportional to these two sides. And then again, to solve all these proportions, we just set the cross products equal. So let's go take a look over here. It says find the missing side length indicated. Well, I've got some parallel lines being cut by transversals. So this is situation number one, where it gets cut proportionally. So I can say that I'm going to call this X. X is to 2. So this little piece is to this little piece, exactly as 15 is to, and then I got to be careful not to use the 12 because 15 is this piece. So I need to make sure I grab this piece over here. So I have to do 12 minus 2, which is 10. And then I can say 10x, cross multiply, is equal to 30, and x is equal to 3, and I'd be done. On the next one, same thing. I'm going to set up a proportion. I'm going to say question mark x. Now there's lots of things I can do here, and I'm going to stop and pause a minute before I go set up my proportion. I'm going to call this question mark x. I can say x is to 30 as 77 minus x is to 25. That's totally legal to do that. Or I could say, if I want to make it a little simpler, I can say x is to 77, like the whole way, as 30 is to this whole way. So you can set them up. All the parts are in proportion. So it's kind of nice. You have an option as to what you want to set up with that. So let's go. I'm going to go with x is to 77 as 30 is to, what's this whole way? 55. That's legal. And just to show you, I'm going to set up another one over here because I want to make sure you're clear on what you can and cannot do. I can also say x is to 30 as this piece, which would be 77 minus x, is to 25. When I solve both of these, I'll get the exact same answer. Let's go do it. On the first one, I'd have 55x equals, and then I go to a calculator and do 77 times 30, and I'd get 2,310. I would divide both sides by 55, and I'd get an x of 42, and I'd be done. On this one over here, I'd have 25x equals, and I'm just showing you two ways to solve these because there's a lot of ways. And I'm going to show you these two. So I'm setting the cross products equal again. I'm going to distribute this in. I'll get 25x is equal to 30 times 77, which I already did on that cross product there. So that's 2,310 minus 30x. I'm going to get my x's on the same side by adding 30x over. I get 55x is equal to 2,310. Notice I have the exact same expression. So the reason I picked this one is because I like to deal with these singular terms versus this one with the subtraction in it, but it doesn't matter, so whatever makes more sense to you, go ahead. Let's go look at the next one. This is situation number 2 up there in the concept box that says that these sides are split proportionally to these sides. So again, if I'm going to call this x and I want to say this side is to this side, then I have to call this one x minus 7. So you've got to do sometimes a little legwork before you get started, but I would say 7 got split with x minus 7 proportional to the 28 and the 20. So again, I'm just saying this piece is, here I'm going to go with a different color here so you can see it. Let's go with the blue. I am saying this piece is to this piece as this piece is to this piece. And then again, we'd just set the cross products equal. We'd have 140 equaling 28 times x minus 7. And we'd distribute the 28 in, and we'd have 140 is equal to 28x minus, and then we need to do 28 times 7 on a calculator, and that gives us 196. Adding that over to the other side, I get 230 equals 28x 36. There, that's getting messy. Let me write that a little neater there. I've got 336. So let's take 336 and divide it by 28. And we get a nice 12. X is equal to 12. And we're done. So we're just using those two relationships up above in the concept box to set up some proportions and then solve them. So same here. We're just going to set this up that this is to this. 8 is to 10 as this, which isn't 28, it will be 20. 20 is to 3x minus 5. And then again, we'd set our cross products equal and solve for x. And I'm going to have you pause the video and do that on your own. The next setup, all right, we've got the parallel lines being cut. Everything's cut in proportion. So I think what I'm going to do is do 10 minus 4 to get a 6 on this one. And I'm just going to set it up. 4 is to 2x minus 10 as 6 is to 9. And I can reduce 6/9 if I would like to, or I can leave it. That's completely up to you. I'm just going to leave it for now. 4 times 9 is 36, and I'll have 6 times 2x minus 10. 36 then will equal, we're going to distribute this in, 12x minus 60. I'm going to add 60 to both sides. And I get 96 is equal to 12x. Dividing both sides by 12 gives me an x of 8. And I'm done. And last one up. We're going to set up a proportion again. This is to this as this is to this. Or this is to this as this is to this. You just got to be careful that you grab those corresponding parts, but other than that, you're safe to set that up however you want to. So I'm going to do it the way the theorem says, which is to say this piece across from the angles is to this one, which isn't 24, it'll be 14. So remember to do some subtracting with those if you need it. And again, now I'm going top to bottom, so I have to grab this one first, top triangle to bottom triangle. So 2x minus 5 is to 21. And then again, we'd set our cross products equal and solve for x. We are skipping 1.5, and you will now do worksheet 1.6. I would like you to show me the first 3 when you're done, and if they're good, I will allow you to skip some of the rest. So have a good one. That's why it's always good to listen to the videos and not just copy down what I'm writing, because otherwise you wouldn't know that I might let you just skip after 3 problems. Have a good one, guys. Peace out.